Example number 18. Suppose that the graph below is the graph of f prime of x, the derivative of f of x. Find the locations of all relative extrema and tell whether each extreme is a relative maximum or minimum. Now, this can be one of the most confusing concepts there is. So we have to be really careful to avoid thinking this is a maximum, because that's not what this graph means. This graph is describing how the original graph changes, okay? It's describing the slope of the tangent line. So what's happening in this region is that the slope of the tangent line is negative, because those values are negative. And in this region, all the way from here to here, the slope of the tangent line is positive, because those are above the x-axis. So those function values are positive. And then again, the derivative is negative here. So let's make a chart so we can think about what this actually means. Okay, we have our derivative at 0 here and here. So once you've taken the derivative and you've set it equal to 0, those are your critical numbers. Well, our derivative is 0 at -6, and our derivative is 0 again at x equals 0. On the left of -6, we have a negative for our derivative. In between, we have a positive for our derivative. And on the right, we have a negative again. So what that means is the slope of the tangents are negative. Remember, these are tangent lines. Until we get to -6, then the slopes of the tangents are positive until we get to 0, and then the slopes of the tangent are negative. So look, I'm drawing the tangent lines in, and that kind of shows me what the original graph would look like. So we have a low point or minimum here and a high point here. Now, we don't have enough information to find the exact values, but we can say where they are located. And so some of the choices aren't shown here, so I'll just write them out. The function has a minimum at x equals -6. And the function has a maximum at x equals 0. So when you're looking at the graph of the derivative, you've got to look at the sign so you can tell if your function has a negative tangent line or a positive tangent line. And you can tell where it's changing from negative to positive, you're going to have a minimum, and positive to negative, you're going to have a maximum.